to heat up an object, we need to raise its thermal energy, so we need to apply energy, we need to heat it up. And the amount it heats up depends on the specific heat capacity of the material. So when we're heating an object up, we can waste some of this energy. For example, if I've got a beaker of water and I'm heating it up, so let's say I'm heating up using a Bunsen flame underneath it, the water is increasing in thermal energy. But as that's happening, we are dissipating energy to the surroundings, which are represented by these arrows. And we can reduce this by using insulation. So if I draw exactly the same beaker with exactly the same volume of water, so the same mass, and I put the same heat supply, heat source, so everything in this example is exactly the same. However, this time I wrap it in insulation. So what's going to happen now is less energy is going to be transferred away, less energy is going to be dissipated, so it's going to be more efficient, and we'll talk about efficiency in the next video. If I use even more insulation, so nice thick insulation, there's going to be even less energy dissipated, And we can measure this using something called thermal conductivity. And the greater the number, the bigger the number, the larger the number, the more energy is dissipated. For example, in this case here with no insulation, the thermal conductivity, let's say, is 3 watts per meter degree C. And I'm just using these units as an example of something they could give you. In this case here, we've got some insulation, so it's going to lose less heat, it's going to lose less energy to surroundings, less energy is going to be dissipated, so it's going to be a smaller number. So I'm going to call it 1.5 arbitrarily. And in this last example, we've got nice big thick insulation, so even less energy is dissipated to the surroundings, so the thermal conductivity is going to be even smaller, so let's call it 0.5 watts per meter per degree C. So the better the insulator, the lower the thermal conductivity. So all these numbers are the thermal conductivities. We can also prevent energy dissipated to the surroundings by using something called lubrication. So for example, a car's axle, which is what the wheels are attached to. As you can see, I'm a great artist. As those axles spin around inside the wheel, there is friction. And that friction, as we talked about energy transfers earlier on, causes thermal energy. And if we're wasting energy as thermal energy, the wheels aren't going to rotate as quickly, so we'd get less speed, and therefore we'd get less kinetic energy. However, if we use something called lubrication, which is like oil, if I draw some oil on it, again, my great art skills, put some oil on it, we get a decrease in friction. We get a decrease in friction, we get a decrease in thermal energy. So this time, instead of having less speed, we get more speed. And therefore, instead of getting less kinetic energy, we're going to get more kinetic energy. And that makes it more efficient. So there's 2 ways of reducing energy wasted, energy dissipated to surroundings. We can use insulation, and the thicker material, the lower the thermal conductivity, so the better the insulator. Or we could just use a different material that's got a lower thermal conductivity. The other example is by using lubrication, which is, for example, things like WD-40 or oil, and this is usually on things that rotate or slide across each other. By using lubrication, we reduce the friction, we reduce the thermal energy, we get more speed, and therefore we get more kinetic energy.